Today we'll start two hinged arches. So already we have discussed in last semester that the three hinge arches. So in three hinge arch is a determinate structure, and one hinge is present at the crown. You know the different parts of the arch. So the bottom part, that is the abutment, and the top portion, that is called the crown, and the support to support length, that is called the span. This is your support, and support to support, this is your called the span, and this is your called the crown, and this is your called the stringer. This is the height of the arch. This is the span. So support to support length. So this height is called the height of the arch. So you see, in the case of beam, so the beam is resting over only these two support. That case, so there is not coming any horizontal force. But due to the chord nature of the arch, so here you have to design the abutment also by considering the horizontal force. So the horizontal force is induced at the abutment support, and you have to consider when you design the abutment. That's why this is the force is coming in the case of arch. Here we will discuss that is the already that is three hinge arch, how to analyze. That is the parabolic arch and the circular arch, how to draw the bending moment, and how to find out the bending moment, the normal thrust, radial shear. Everything in the case of three hinge arch. Similarly, here also we'll discuss in the case of two hinge arch, we'll find out that bending moment, normal thrust, radial shear. That three hinge arch is a determinate structure. One hinge agent at the crown. But in the case of two hinge arch, there is two hinge at two support. There is the third hinge are absent in the case of two hinge arch. Here there is no hinge. At the crown there is no hinge in the case of two hinge arch. Only the hinge are present at two support, A and B support. The cross section of arch may be of different shape, commonly used circular and parabolic arch. Here also commonly used the arch is circular and parabolic. Arch with varying shape are also used. So with varying shape of arch is also used. So here you see hinge arch is indeterminate structure. Why this is your indeterminate structure? This is your indeterminate to 1 degree. How this is your indeterminate to 1 degree? Because you see at hinge A, there is two force, horizontal HA and BA. Similarly at hinge B, there is also two force, HB and BB. Total how many forces? 4 forces. And how many static equilibrium equations are available? 3 equations available. That total number of forces or reaction component VA, HA, BB, HB, and number of available equations are 3. So degree of indeterminacy is equal to the total number of forces minus the number of static equilibrium equations available. So here 4 minus 3 is equal to 1. The degree of static indeterminacy is equal to 1. So normally arcs are subject to vertical force only. Hence equilibrium of forces of horizontal direction gives HA is equal to HP is equal to H. If there is no horizontal force, so HA is equal to HP is equal to H. Because only when there is having the vertical force. So normally this is acting on the arch. The horizontal force H may be taken as a redundant force. This horizontal force H, HA is equal to HP is equal to H. So this is generally taken as a redundant force. The expression for horizontal force may be calculated using two methods. So you can find out the horizontal force using two methods. One is your first theorem of Castigliano. This is your strain energy principle. And the second method is your unit load method. So using these two methods, you can find out the horizontal force. So first we'll discuss that is the first theorem of Castigliano. So this is also called the strain energy principle. Strain energy principle. Let Mx be the bending moment at point P xy on the arch. Let us take one point here P and xy, P xy in bracket xy. This point here P xy. This is at a distance x from the support, horizontal distance, and the vertical distance y from the horizontal line that is passing through AP. So xy, so the coordinate p xy, this is x and this is y, so this is your pxy. Let mx be the bending moment at point pxy on the earth's support A being taken as origin. Mx is your the moment, bending moment at the point P. Let m dash be the beam moment due to apply load on beam of span equal to that of arch P, and h be the thrust. So m dash is the beam moment. What is the load you are acting? What is the load you are acting? So due to that load, considering as a beam, so the moment here is equal to m dash. The moment at P is equal to m dash. By considering the vertical load, and you have to find out the moment as a beam moment, like that moment is equal to m dash. M dash be the beam moment due to apply load on beam of span equal to that of arch. Mx is equal to what? So here you have to find out that mx. So mx is equal to that beam moment. Mx is equal to beam moment minus the moment due to the horizontal force. Beam moment you have to find out by considering the vertical force. So the beam moment is equal to, here the beam moment m dash is equal to va into x. But you have to find out that moment, total moment mx. So total moment mx is equal to beam moment minus the moment due to the horizontal force. So beam moment is your m dash minus h into the vertical distance. You have to find out the moment of this horizontal force about the point P. So what is the moment? So h into the perpendicular distance y. So the moment mx is equal to beam moment m dash minus h into y. Mx is equal to m dash minus h into y. So this is the beam moment. So this moment is you have to take only by considering the vertical load, and this moment is due to the horizontal force which is acting at the support. So this is the total moment at the point P, xy. Then you know the strain energy stored in the arch. You know that in last semester. So what is the formula for the strain energy? So strain energy is equal to integration of mx square ds by 2ei. Mx square ds by 2ei. You know what is the moment at the point here at point P? You know what is the moment mx? Mx is equal to beam moment m dash minus h into y. So you know what is the moment here mx. So you know that is the strain energy principle. So this is the strain energy U is equal to mx square ds by 2ei. So mx is, you know, here you know the mx, m dash minus hy. So put this mx here. After putting this value mx, m dash minus hy bracket whole square into ds by 2ei. But you know, according to Cauchy-Galenos theorem, first theorem, differentiation of strain energy with respect to force give the horizontal displacement along the direction of the force. This is the first principle, Cauchy-Galenos first principle or first theorem. Du by ds is equal to horizontal displacement at one end with respect to the other end. Here you see the supports are not yielding. Du by dh is equal to 0 since supports are unyielding. Due to non-yielding of the support, this horizontal displacement is equal to 0 because the partial derivative of strain energy with respect to force give the displacement along the direction of the force. This is the Cauchy-Galenos first theorem. But here you see as the supports are unyielding, so there is no horizontal displacement. So partial derivative of strain energy with respect to force is equal to 0. So you put here, so here you put, because when you first you take the partial derivative of strain energy with respect to h, with respect to force means you have to take horizontal force h. After taking the differentiation of u with respect to h, so you will get d by ds integration of m dash minus hy whole square into ds by 2ei. This is. Then, so after taking the differentiation of this one, so integration 2 m dash minus hy and in bracket minus y ds by 2ei is equal to 0. Then just to multiply this one, so minus m dash y minus hy square, and this is 2 and 2 cancel. This is integration of minus m dash y minus hy square into ds by ei. Then just you take both side this value and this value take both side. So h here h y square integration of ds ui, h integration of y square ds ei, and is equal to integration of m dash y into ds ei. Just to multiply this one and also integration and take both side of the equality. So this is the expression. Then you can find out from this expression what is the horizontal force. So horizontal force is equal to integration of m dash y into ds by ei, this one, divided by integration of y square into ds by ei. So this is the horizontal force. Then the another method, unit load method. So here what you have to do, that B, this is your hinge support, A is also hinge support. So that B replaced by roller support. We get the basic, so after replacing the roller support, what is the whether this is your determinant or indeterminate. So after, if you will replace this one, that become the determinate structure, because you see for determinate structure, if there is your 3 force and 3 static equilibrium equation, then easily you can find out, and that becomes the determinate structure. Here you see, so this side is your hinged, there is your 2 force, one vertical or horizontal, and this is your roller support, means only vertical force, there is your no horizontal force. So this is your, this becomes the determinate structure. H here, H is equal to 0. Here there is your no horizontal force. Hence bending moment same as beam moment m dash. So bending moment is also your same as beam moment m dash. Let the bending moment due to unit horizontal load at B be m. So due to unit horizontal load, the bending moment at B is equal to m. Due to unit horizontal load at B, due to, if you apply the unit horizontal load at B, so due to this unit horizontal load, what is the moment at B? So this is equal to small m. This is equal to small m. Let the bending moment due to unit horizontal load at B is equal to m, is equal to small m. Hence, at any section P xy, the bending moment due to unit load is your m. What is the bending moment due to unit load? M. Unit load is your acting here. Unit load is your acting here, and take the bending moment from this point. So 1 into y, the force into the vertical distance. This is the bending moment at B due to unit load. So this is the unit force you are acting here at B, and what is the perpendicular distance y? So what is the moment due to the unit load? P is equal to 1 into y. This is equal to y. So this is the bending moment at P due to unit load. So this is equal to y. But you know the horizontal displacement of roller end, you know, by unit load method, m dash, capital M dash into small m into ds by ei is equal to m dash, and small m is equal to y, because this is the moment at P due to unit load. This is the moment at P due to unit load is acting at B. So what is the unit load acting here? So you have to take what is the moment from this point P. 1 into the vertical, 1 into y. So this is equal to y. So m is equal to, small m is equal to y. So you have to put this small m value here. So m dash integration of capital M dash y ds by ei. So this is equal to 1. Now consider the inward displacement of roller end when a horizontal force H is applied as in figure 3. Then what you have to do, just to apply the inward force here. First to apply unit load here, and the displacement, this is the displacement, and due to this displacement, this is the expression, horizontal displacement expression. Then you apply the horizontal force here, H, at B dash. Apply horizontal force at B dash, and that will come to this position here, this one. So here you go, this is the B. So apply inward horizontal force, inward horizontal force. Now consider the inward displacement of roller, and when a horizontal force H is applied as in figure 3, displacement of B due to H. The bending moment due to H at Pxy is Hy. What is the bending moment? When you will apply the horizontal force and due to that force, so see the inward displacement takes place delta, and due to this one, what is the bending moment at P? So H into the force you are acting H, capital H, and what is the perpendicular distance Y? So capital H into Y is the moment at the point P. At the point P. The bending moment due to H at Pxy is very equal to Hy. So the horizontal displacement of rollers is very equal to, what is the horizontal displacement of rollers? So this is the moment capital M, M test, capital M test, and this is the small m, y, and ds by ei. So horizontal displacement of rollers is very equal to integration of hy into y into ds by y. This is your horizontal displacement of roller is very equal to h integration of y square ds by this one, y square ds by ei. So this is your equation 2. For consistency condition, the support of the arch must be unyielding. Actually, you see, so here the support is unyielding. Here the support is actually unyielding. And equation 1 and 2 must be equal. This is equation 1, integration of capital M dash y ds by ei, and this is your equation 2, h integration of y square ds by ei. So equate to these two equation 1 and 2. This one, integration my ds by a, and is equal to h integration y square ds by a. Then from this relation, you can find out what is the horizontal force. H is equal to integration of m dash y ds by a divided by integration of y square ds by a. Using this relation, you can find out the horizontal force by unit load method, or this is also called the consistent deformation method. So now you are clear, that is how to find out the horizontal force, that Castigliano's first theorem method. Then second one is your unit load method. Then coming to the analysis of two hinged circular arcs. Here you see two types of arcs here also, two hinged circular and parabolic. So first we'll discuss that is your circular arch. This is circular arch. This is your H. And this is the point P, XY. At a distance, this is support, this is your support P. So this is your X distance and this is your Y. The coordinate is your P, XY. And this is the small angle theta from the center line. And this is the radius of the circular arch. Take a point at an angle theta from the vertical line or from this support A. So this is the coordinate is your XY. And from this line, this is your angle. And this is the, this angle is your d theta. And this length is your ds. This curve length is your ds. And the length of the circular arch is your L. Consider the circular arch span L and rise H. This is your called the rise from this to this. Let the radius of the circle be R. Then for any point P, X, Y, what is the Y distance? This Y. This length is your Y. So how you will find out this length? Because you know here this is radius of the arch, and here this is also radius of the arch. What is this length? From this to this is your, because if this is your angle theta, so from this to this is your r cos theta. From this to this is your r cos theta, and total is your r. This is r cos theta. So what is the this length? Because this is total is your r and this is your r cos theta. So you know this is, what is this value? R minus r cos theta. This is your equal to r minus r cos theta. So if you know this one, this length, r minus r cos theta, then easily you can find out y. So y is your equal to, you know, this is the rise h, and you know this is also, this is r minus r cos theta. So y is equal to h minus in bracket r minus r cos theta. So y is equal to h, here you take common r into 1 minus cos theta. Then you take the differentiation of ds. ds is equal to r d theta. So this length is equal to the radius into the angle between them. Angle between them. R into d theta is equal to ds. And you know what is the moment? So what is that moment at this one? X. At a distance x, what is the moment? Mx. So mx is equal to b moment m dash minus hy. this is your B moment, and this moment is due to the horizontal force, because this is the horizontal force H, and this is the perpendicular distance Y. So here what is the moment Mx? Mx is equal to M dash minus H into Y. So M dash is equal to the beam moment, and V is the beam shear. We will take the free body diagram. This is the beam shear, and N is the normal thrust. N is the normal thrust. Already we have discussed in the 3 inch also. Normal thrust, and Q is the radial shear. This is your horizontal force. This is vertical force, and this is the normal thrust, and this is the radial shear. Normal thrust and radial shear. So this is perpendicular to each other, and the vertical force and the horizontal force, this is perpendicular to each other. If this angle is your theta, because this angle is your given theta, this angle is your theta, we can normal thrust, that is your normal to this one, and radial is your, this is along this direction. So this is the radial, and this is your normal. So here this is the angle theta. So here when you take, this is your N, and this is the horizontal force, this is also angle theta. If this is angle theta, then what is this angle? This angle is your 90 minus theta. The vertical force and the normal thrust, angle between them is equal to 90 minus theta. And the horizontal force and normal thrust, the angle between them is equal to theta. Take these 4 forces, result the force V and H along the normal direction and along the radial shear direction. So when you will find out this N, normal thrust, so you have to take the component of these 2 forces. So H component along this direction and V component along this direction. N is equal to what? So H, and this is the angle theta. So N is equal to H into cos theta plus V into cos 90 minus theta. But you know cos 90 minus theta is equal to sin theta. So N is equal to H cos theta plus V into sin theta. V sin theta plus H cos theta. So this is the normal thrust. So at any point, so the normal thrust is equal to V sin theta plus H cos theta. Then you result these 2 forces along the radial shear direction, because normal thrust and radial shear is perpendicular to each other, and V and H is also perpendicular to each other. And this is the angle theta, and this is the angle 90 minus theta. If this is your angle theta, then this angle is also 90 minus theta. Angle between the Q and H is also 90 minus theta. So just to result these 2 forces along this direction, Q. So Q is equal to, so here you see this is V. So if you take, if this is your 90 minus theta, then this angle is your theta. If you draw one line here along this line, V cos theta, this is same direction, V cos theta, the component of V along the radial shear direction. So V cos theta, and this is along the direction of Q radial shear. And when you take the component of H along the radial shear direction, so this is your H into sin theta. So V cos theta minus H into sin theta. So this is your equal to the radial shear. So this is the normal thrust at any point, and this is the radial shear at any point in the 2 inch circular arch. So then I will discuss one question. Determine the horizontal thrust developed in a semicircular arch of radius R subjected to a concentrated load W at the crown. So this is the load you are acting. This is your semicircular arch. Load you are acting at the crown, and this is the horizontal force, and this is the vertical force VA, VB at the support A and B. Let us take one point at a distance X from support A and Y from the horizontal line. So what is the coordinate PXY? This is at an angle theta from this vertical line, from the rise. So this is at an angle theta, take this is the point P, or at an coordinate X and Y. So this is the point. So due to symmetry, here you see this is the load you are acting at the crown. So here this is your symmetrical arch. So due to this symmetry, what is the vertical force at A and B? So VA and VB is equal to W by 2. V and VB is equal to W by 2. So Y is equal to R into cos theta. Then what is the X length? X length is equal to, so this is your R, or this is also L by 2, because the total length of the arch is your L. So this is L by 2. So L by 2 minus R sin theta. So this length is equal to this length is equal to r into sine theta. This component of this one. So this, because this is the radius and this is theta and this is 90 minus theta. So r into cos 90 minus theta, that is equal to r sine theta, this length. So this total is your L by 2 minus r sine theta is equal to x. X is equal to L by 2 minus r sine theta. What is the beam moment? M dash is equal to, what is the beam moment here? M dash. So beam moment that only have to take due to the vertical force. So M dash is equal to VA into x. The vertical force VA and the horizontal distance is x. So VA into x. So but you know VA is equal to W by 2 and x is equal to r minus r sine theta. Just to put here. Then you know how to find out the horizontal force. So horizontal force is equal to integration of m dash y ds by ei, then integration of y square ds by ei. Then just you take, this is the ei is your constant. So m dash y ds is equal to, so here you take m dash. This is m dash w by 2 r 1 minus r sine theta. So just you put here m dash, and this is your integrating from 0 to pi by 2. So here you take the integration from 0 angle to pi by 2. Similarly, this side and this side you have to take the integration. So both sides you have to take twice integration 0 to pi by 2. W by 2 r 1 minus sine theta into y ds. Y ds is equal to what? Y ds. Because y is your r cos theta and ds is equal to r d theta. Then after taking this simplification, you have to know that how to take the differential integration here. So you take 1 minus sine theta is equal to t. dt is equal to minus cos theta into d theta. Then you put this value here. So after putting here, after a simplification, so the integration of m dash y ds is equal to w r u. This is the integration w r q by 2. Integration of m dash y ds is equal to w r q by 2. Then take the integration of y square ds. So y, you know what is the value y? Y is equal to r cos theta. So here you take the r square cos square theta and twice integration 0 to pi by 2 into ds r d theta. Similarly here, this is also take the simplify this one equation. So 2rq 0 to pi by 2. So you know cos square theta is equal to 1 plus cos 2 theta by 2 into d theta. Then after simplification, this is the equation. Then after putting the value 0 and pi by 2, so here the integration of y square ds is equal to pi r cube by 2. Here you got what is the integration of m dash y ds, this one, and here you got the integration of y square ds, this one. So h is equal to integration of m dash y ds divided by integration of y square ds. So just you put this wr cube by 2 into this value. So here the horizontal force is equal to w by pi. So this is the horizontal force, so that you can find out. Now all are clear. So how to find out the horizontal force?